Hello everyone, this is Deepak Joshi, and today we are going to talk about an interesting concept that is progressive discovery of tool. This is one of the problems that I faced uh, during the implementation of a lot of agents that has more than like 50 tools. Think of it as an e-commerce website. You're building an agent for e-commerce website, so there are a lot of things that happens in an e-commerce website: orders, returns, refunds, then like user grids or user order history, then shipment, and then a lot of other things. So you have to like build an agent that has access to all of this. If you'll calculate, like it will be a lot of number of tools, right? And uh, there are two things that will happen, but I don't want to go into that just right now. I want to tell you a small story, and then we can figure out why do we actually need this. And yeah, let's uh, start with this. A very small story, guys. So here we have a person, like recently I've started consuming coffee, so probably I'll say me. Uh, was like who went to a hotel and asked the waiter for the menu, and he came up with this big menu. Happens to me a lot of time, so I'm confused now. I was like, I just wanted a coffee, but you're giving me a list which is like a kilometer long. So how can I uh, choose, right? So it's an issue, like it's loading everything. So this similar situation happens with an LLM as well. Let's say this is an LLM and you're providing it with a lot of tools, like a lot of tools. What are these tools? These tools has their name, right? Their description, their schema, and then on top of that you have a system prompt. That system prompt is also long, like explaining which tool to use and when, like providing an add-on context to the LLM, right? But yeah, coming back to this, this is confusing, right? uh, to me as well. What could have been easier is something like this, right? If I entered in the hotel and I asked waiter, and the waiter had like different menus, like for appetizers, for desserts, for sides, or for beverages, and then he can come and give, like if I'll say I want a coffee, then the waiter can go and give me the beverages menu, and then I can select, oh, I'll have an espresso, uh, not latte but espresso, or like cappuccino, or something that I can try. This would have made the waiter and me like more relaxed, right? We all know what's happening and we have things to choose from. So think of it of very similar situation. Like previously what we had is like a hell lot of tools, right? So if we would have organized everything in a manner such as, let's talk about an ecom, uh, such as orders, then returns, right? Then uh, shipment, then uh, user grids or other stuff. So if we would have organized all of this, then and given LLM some sort of reference, okay, we have these four categories. Now the order has like n number of tools, let's say six. The returns has like eight tools. Shipment has like nine tools. User crates has like two tools. We don't have to load all the tools in the initial call to the LLM. Like what we will load is like only the categories. So we have these four major categories, and if there is any tool that you need to utilize from these categories, go into orders, look into tool names, and pick from those tool names. I'll uh, let's try to understand it in a detailed manner. Let's say we have LLM. How we do it in general is we have an LLM. We give LLM all the tools. Let's say this is one tool, this is two, three, four, five, six, seven, eight, right? And all these tools will have, how do we classify tools? With schema, right? Name, then it has a description, then we give it a schema, right? So assume like one tool set, like one tool is occupying, let's say 500 tokens, right? I'm just assuming, okay, 500 tokens, and we have like 10 tools. How many tokens does the 10 tools will occupy? I think 5,000 tokens. Think of a system which has like 100 tools. Okay, so 500 into 100, that is like 50K, I would say. Uh, 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 I think my mathematics is wrong. No, my mathematics is correct. So it will be 50K, right? Like 50K on the first load, like on the first prompt. You, let's say the user came in to your agent, like your ecom agent, and the user said hi. But on the first user prompt, you're like attaching 100 tools with 50K token context into the into user prompt, and then you're passing it to the LLM. The cost will skyrocket, right? There are fair enough chances that the LLM can hallucinate as well. I was just looking at the stuff just to understand stuff in a better manner, like, right? These are the context window, and like these are the input prices. Like 5.2 has 400K. I was looking at DeepSeek R1 have like 128K. Think about this, like 50K on the initial call, like uh, close to 50% of input tokens you have already utilized just by loading the. I think this is a little zoom out. Let me just zoom in for you guys. Oh, it's not happening. Let's do it from here. Yeah. So think about it, like if you're using DeepSeek R1 for your agent, ecom agent, and you yourself utilize like 128 token in the initial, like 50K tokens in the initial run, which is like very close to 40% of it, like, and you're it is costing you something, right? Like input token has a cost associated with it, and if it happens every and each and every time, then think of the scenarios, like think of the cost that you'll be accumulating, and which is like of no use, right? So what's the better way of doing this? The better way is like the stuff that this person, the waiter, did. What he did, he organized everything. He was like, okay, let me just ask what you would like to have, and then what I'll do is I'll go and give you the menu for that particular item, right? So what it did is it did the progressive discovery. It first understood, okay, so this person wants coffee, which belongs to beverages. So now I'll go and look into the beverages menu and give it to him, or like the LM will scan and then figure out, okay, what sort of coffee this person wants, right? Uh, so for this, like if we can do something like this, what we can do is, like we did the calculation, right? 50,000 tokens, but we if we would have created a category. So in the first, let's say 1, 2, 3, 4 categories, this occupies 50 tokens max. Like I'm max 100 tokens we can say as well. In the first LLM call, what we are doing, we are not binding any tool. What we are binding is the references, right? So plus 50 tokens, like 50 tokens plus system instruction plus the user input. Like this is the whole cost. The cost reduces, right? The cost reduced, but I'm just curious on the part how it will go and access the tools, right? That is also a very complex stuff to do. Now, how to do it is pretty naive. What we can do is we can give a sort of directory structure to our tool callings. Let's say we are building a communication module agent. We have a Slack directory for tools. We have like Gchat. We have uh, Teams, and we have like Signal, right? These are the four main folders. Now, Slack will contain a lot of tools: list messages, get messages, send messages, schedule messages. Gchat will have like list messages, schedule messages, calls, and a lot of things. Teams will have similar tools, and Signal will also have similar tools, right? Now, if we'll see, we have structured it like this only. Now, what will we will tell LLM is we will have a uh, like a lot of people name it in a lot of different ways. Like Some people call it tools registry. Some people just have the list directories and then go into it. So let's call it tool registry, sort of like the tool registry is very high level hierarchy, which is Slack, GChat, Teams, Signal. A user comes in and says, I would love to write a message to Deepak on Signal saying how is he doing and how's everything going with him. Okay, so now the LLM knows, okay, this particular chat message is sort of what I can understand is it is a send message and to Signal. So what it will do, it will come to Signal, it will have list tools now. So it will list the tools and it will see, do we have a tool to send messages? Oh, we have. And then it will not utilize that tool. It will get the schema of the tool, list schema of tool send messages of Signal, right? You can think of it like this, like list uh, message send of Signal, right? So it will, and schema, something like this. So it will get the schema of it, and then the LLM will fill that schema and execute that tool. So look like how much tokens we will save using this, right? But there is like pros and cons of it. Like I have just come up with an estimated uh, stuff like which we just calculated, right? uh, like without tool discovery it was like very close to 5,000, like more than 5,000, but with tool discovery we will have only like 428 tokens, like a ballpark estimate. I have personally used it in a very similar example that I showed you for a communication module. Like it was a high level communication module for admins, like which can have exchange. If you have heard of Azure Exchange or like Azure Exchange is a piece of shit, but Azure Exchange, and then you can integrate like your Outlook, your Teams, your then if you are like on Google, then you can integrate your GChat, right? You can integrate Gmeet in it as well, and Gmail as well, right? Exchange includes like a lot of admin stuff, like creating a like enabling forwarding and blocking forwarding and everything. So you can imagine, like I'm just telling you all these things because you can imagine the number of tools we need to create. If there is an MCP, that's good, but if you are working on like creating creating tools, then it is going to be a big number of tools, and for those big number of tools this is helpful. But if your agent is like less than 10 tools, don't use it. I don't think this is going to be useful because first it is less than 10 tools. You're like overcomplicating the system by introducing a tool registry for like 10 tools. Also, like if most of the tools are like being invoked all of the time, then I don't think uh, something like this, like progressive discovery of tool is meant for that. Progressive discovery of tool is meant for the cases where LLMs are not certain, like which like it is not certain that this particular thing is going to utilize this. So they discover it by themselves, right? So one of the way of like reducing uh, input tokens. Okay, this is one of the very good example, like very good stuff that I found. Like without discovery, the LLM finds out, oh, there are n number of tools like get user, create user, update profile, delete account, reset password, order history. Like I took the example of an e-com website, right? Like send SMS, list issues, create coupon, payout, get balance. LLM is like like confused. What's happening here? There are very big chances that it can like hallucinate and can pick a wrong tool. But instead, on the other side, with like progressive discovery, it has a orders folder. So it goes into orders folder. Like now it understands, okay, domain selected. Then it lists the tools present in orders folder. So okay, there are 6 tools: track order, cancel order, modify order, return order, order history, order details. Great. What do I need to do? The user query was initially related to track order, so I'll pick track order and get the schema for track order, which is like order ID and include items, and then I'll get the output. So like a lot of to and fro. I know like it is a lot of to and fro, but like which slightly increases the latency. But I think like a better way of doing this is this way. Instead of giving LLM all the tools in the first way, we should like give it the hierarchical topmost hierarchical structure, and then it can go and discover everything by itself. So uh, this is something that, yeah, let's understand. I have a coding example for this as well, which is like mostly hard coded stuff, but I would love to show you that post this. So let's talk about the categories. So this is the AI support agent, right? Now I have classified into, you have to like invest invest some level of thinking in classifying the tools. If you're working on a communication module, then how you can classify it as whether it is Exchange, whether it is uh, Outlook, whether it is like Teams, whether it is Calendar, whether it is um, I would say anything, and then you can build tools in it. For example, in uh, let's say in calendar, so you can have get mails, get drafts, send update drafts, send drafts, send mails, search mail, like find query or something like that, right? So you have n number of tools in that particular, and you can further do this classification if you think, for example, in Slack, for example, in Teams, you can classify it in like groups, if this particular tool is related to groups or like non-group or direct messages, something like that. However you would like to engineer it, like it's a good problem to have, like to think about, but like I'm just giving a ballpark idea of how progressive discovery of tool works. So this is one of the example for e-com website where we came up with the classification for orders. So orders will have 6 tools, payments will have 5 tools, shipping will have 5 tools, product will have 4 tools, accounts, communication, knowledge base, reviews, promotions, analytics. Uh, there are like 2 types of analytics, inventory, right? Uh, yeah, I think you can product analytics and user analytics, right? So if you like count all the tools, 11, 16, 20, 25, 29, 32, 35, 39, 42, 45, and 48. So like total 48 tools. Think if we would have given all the 48 tools in the first go to the LLM, it would have been like a big context window for the user input, along with like chances of LLM getting like hallucination is the next part, but like the big stuff is like cost. So something on that front, right? So if we have classified everything in like 8 category, like more than 8, I would say 4, 8, and 12 categories, and we'll only pass these 12 category names in the initial front, and then uh, the LLM will decide, okay, this particular problem statement is related to payments. Now I'll go into payments and get the tools which are mentioned in payments. So in payments, I have 5 tools. Okay, I have to use the second one. So I'll go into the second one, and what I'll do is I'll get the schema of the second tool, and then I'll execute that second tool. So it adds some sort of complexity from the engineering perspective, but like it makes our agent like more robust and solves problems in a better way, right? Let's look at this. So here it is, like list domains, like so it has like domains or like tool registry, right? So it discovered 11 domains. Now so it has another tool which is like list domains. Like how are you doing that hierarchy structure is by list domains and list tools in domain. I'll show you that in code. Like I have a hard coded stuff with me. I'll present it to you to provide some sort of reference on that front. So now it gets goes and like tries to get, I'm just doing undo, yeah, get tools related to orders. Agent picks relevant domains and then gets the tools. So it discovers, okay, I have 6 tools with descriptions. Now it asks for full schema. So like if you look at the oh, yeah, if you look at Yeah, if you look at the tokens, like list domains is 35 tokens, 125 tokens, then 126 tokens, right? Which is like total 296 tokens for the whole process. And then uh, like this particular execute will come up with more tokens. Like there will be an output of this tool that will come back to an LLM, but which is like fixed. So that will happen in this non progressive discovery and with progressive. It will happen in the both case. So we'll not talk about this step where we will execute the tool, but we are talking about before that scenario. So if we will use progressive discovery, we will just utilize 296 tokens. And if we'll use like loading every tool at the same time, it will cost like 5,837 tokens. So you can think of like, if the system is very big and the agent is like it has a lot of tools, then in that stuff we can utilize like progressive discovery of tool. I think I'm making sense now. uh yeah, yeah, this is what I was talking about. Like this is not the code base that I was talking about. Like one of the example, like how can we classify stuff. Like, so we have a server for Google Drive, Slack, GitHub, and then Shopify, and then Stripe, and then we have a description for everything. So, and then on top of it, a server will define load. Like remember, like we just saw this like list domains, list tools and domains, and list schema. So we'll define these three tools just beyond those things, right? So list domain will get you Google Drive, Slack, GitHub, Shopify, and Stripe. And if the user query is, let's say, related to Shopify, then what will happen is you will say, okay, list tools in Shopify. So it will go and give you these five: get orders, processing refund, update inventory, track shipment, customer lookup, right? And then you have like now five tools. So the agent will say, okay, the user query, the initial user query is related to get orders. So I need to now do what I need to do, get orders. So give me the schema of get order tool. So it will give the schema, and then that particular agent will execute the tool with the schema understanding and everything. So I think now I'm making more sense. I have one more picture to go through. It is just like I don't know why I edited it, uh, but like uh, good to add in the PPT, like from the uh, presentation perspective. It is a very uh, like if your agent is hitting 1 million queries a day, then like this is the cost without progressive discovery, and this is the cost with discovery. And this all this calculation comes from the initial assumption of like 500 tokens per tool, right? So this is what I think I have for uh, the presentation part. I think what we can do now is we can look at the code base, uh, the example that I wanted to demonstrate. Yeah, let's just look at this in a very detailed manner. So yeah, yeah, I have a README and everything. So like I have a discover agent and the naive agent and token counter. But let's talk about tools. So we have tool domain like order, payments, shipping, products, accounts, communication, knowledge base, reviews. Very similar thing that I showed you in the picture. I hope this is visible properly. And then we have tool description, track order. What is track order? Like how the LLM will get to know I need to use track order. So it will be through this, right? Track the real-time status and location. So like tool description attached to tool domain. Okay. Then we have full tool schema. So like for track order, to execute track order by the LLM, you need to have this sort of schema, right? And then you have like cancel order, its schema, and then like so on and so forth, right? And then you have like the first thing, return all tool schemas as flat list, but which is like returning the schema. Let's not talk about this. Let's go to yeah. This is the executor that I've wrote. Like this is all mook. Let's go to discover agent. So what it does is it just dumps like it has main three tools, right? Just like list domain, list tools and get tool schema. Remember, like I showed you that picture of like uh, I think G drive and everything. Let's I think this is the one that we were talking. Yeah, this is the one that I'm talking about right now. So if you'll see, like we have a server which has like Google Drive, Slack, GitHub, and Shopify. So very similar to that, right? What we'll have is this, those things in the tools, but the main agent will have only three tools, which are these. First, it has to like list domains, and from the listed domains, it has to understand, okay, the user request is coming from this particular tool, so it has to like understand, list the tools for that particular domain, and then looking at the tools, it has to like understand the schema, so it has to get tool schema. It now it has the schema, and then it will execute that particular tool with that schema, right? And I've just added token counters. Now it's a very fair stuff, like very naive code, like no what do we call, like no framework used, like LangGraph or something, very naive LLM calling. I'll start with just the terminal output, right? So it has like these things. I've showed the classification order has text, six tools, payments, and everything. And with the token, like if you have to use orders, all the tools, it is like combined 1000 tokens, 708 tokens. So total tool is 49, total domain is 11, total tokens if loaded at once, which is like 5000. Context consumed, I'm taking the reference for like 128 k window, like GPT-4o I guess had 128k window, uh, and like, which is like 4.6% of it, right? Uh, like scenario one, which is like simple query. Simple query is like you're doing a very simple naive query which will use only one tool. So where is my order? Customer asks about order status, so it needs only one tool, right? If you'll do it without progressive discovery, then what will happen is you will load everything into a single LM call, and that will be like five, approximately 6,000 tokens, and then it will go to the LLM. Like system prompt will be 12 tokens. I'll show you the system prompt, which is like nothing. You're a helpful agent, something, something like that. Oh, 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 oh. Was it in? Yeah, it was in front of my eyes, right? Yeah. Query to tool map. Where is my order? Do it on my like these are just hard coded stuff executor. Yeah. Yeah. Here it is. You're a customer support agent for Shop Max e-commerce, right? Very naive. So that's what I was saying. Let's get rid of this and this as well and this as well. Yeah, we'll just look into this. So the system prompt is 12 tokens. Tool definition is like 6,000, which is like bloated. Customer queries was 13 tokens. Total like 5,862, close to 6,000. So it executed and got the responses. But if we would have done the same thing with progressive tool discovery, what we would have done is like the LM would have like discovered domains, which is like 35 tokens, then explore orders, which is like 135 tokens next, and then it loaded the schema of it, which is like 126 tokens. So the input would have been like only 126, multiple internal React thinking, right? um, Reasoning and action. So you can compare, like here are the metrics: total token consumed, total request tokens, total landed into context, total tools actually used, and then LLM call, which is like 1 and 3. But like there is no cost associated to LLM calls. Cost is only associated to input and output. So like 3 call, which is like reasoning and action. But yeah, you can see like total savings, we save like 92% of the token context window. And then there are a bunch of other scenarios that I've added. Cross domain query, which is like two domains. I want to return my order and get a refund. So it is related to orders and refund as well. So I'll so what I'll do is what it will I'll do first is without progressive discovery. So this 5000 is fixed now. So you have 5837. You have to pass it every time, and it will give you the output. But if you look through the progressive discovery, it will discover domains. It will do explore domains, right? So it get track order, cancel order, because like it is exploring the domain orders first, and then it is exploring the domain payments. So it has like total 135 and 1115 tokens, and then it will get the schema for return order and processing refund, and then it will execute. So here it saved like 85% of the context, and very similar to the other one, which is like multi-step query. Like I have yeah, you can take a look at this. I'm not going to explain this bit by bit to you. Yeah, you can take a screenshot of it. So the overall stuff is right. Like the overall thing is that we have to think of it as like something that we should use when we have like a very big number of tool set, right? And we want to save on context, and we want to save on like some cost as well. So this comes into the that those scenarios. Yeah, I think I was able to explain most of it. We'll see you in some other video. Bye bye, take care.